Here we are with targets 4 and 5 in our second unit. So target 4 is solving an absolute value equation. And so what we need to understand in order to be really good at this target is when you have the absolute value, and let's just start off basic. If you have the absolute value of x equals 4, x could be 4, but it also could be negative 4. So remember, the absolute value is the distance from 0. Distance is always positive. So we have two possible solutions for x. So if you look at our first example here, when we have the absolute value of x plus 5 equals 3, that means that x plus 5 could equal positive 3, but it also could equal negative 3. And so we're going to create two equations in these problems and then solve both of them. So I'm going to subtract 5, and I get one solution for x to be negative 2. My other solution over here would be negative 8. Some problems are going to require more work than others. So for example, on the second one, notice there's this minus 4 outside the absolute value brackets. So the first thing I'm going to do is add the 4 over before I do anything else, before I create those two equations. Then, once you have the absolute value bars by themselves, that's when you create your two equations. So I have 2x minus 3 equals 9, and 2x minus 3 equals negative 9. And then again, I'm going to solve both of these, so using our basic solving skills. Divide by 2, and I get x equals 6. I'm going to do something very similar over here. And I get x equals negative 3. And just a quick reminder, whenever you're solving, you can always plug your answers back into your original equation just to check your work. It should be a true statement if the answer is correct. All right, so on C, again, we're working to get those absolute value bars by themselves. So if you notice on C, the problem is that we have divided by 10. So whenever we have divided by 10, the way to get rid of that is just to multiply by 10. So I'm going to multiply 10 on both sides. So I have the absolute value of negative 8x minus 2 is equal to negative 40. Now let's just think about this for a moment. So can the absolute value brackets ever equal a negative? It can't. It always has to equal a positive number. So this is actually a no solution case. It would come up if you forgot to check for that, then just take your answer and plug it back in and you'll find that they're not true statements. So then you would know something was wrong and hopefully catch that. All right, so on D, again, working to get the absolute value brackets by themselves. I'm going to add 4 to both sides and then divide by 3. So I get the absolute value of x plus 6 equals 2. And now I'm going to create the two equations. Equals positive 2, x plus 6 could also equal negative 2. So subtracting 6 here, I get x equals negative 4. And then over here, if I subtract 6, I get x equals negative 8. And that is that's target 4. So then in target 5, we're going to solve an absolute value inequality and put our answer on a number line. And so we're going to start off, and it's actually going to look very similar to what we were just doing. And there's lots of ways to do this. But the way I start is I think about it as an equation. Negative 2n equals absolute value of negative 2n equals 6. So you would have negative 2n equals 6, and negative 2n equals negative 6. So very similar to what I did above. I just changed the inequality symbol to an equation into an equal sign. So I get n equals -3, and over here I get n equals +3. So on our number line, we have to decide what to do at -3 and +3. So at -3, because there is that equal to component to our inequality, we're going to say it could be -3. So we're going to use a filled in dot. We're going to do the same at +3. And then we're going to test a value outside or in between these two numbers. So I'm actually going to choose 0. I like choosing 0. And I'm going to plug that into our original equation, or inequality. And we're going to see if this is a true statement. So if I simplify this, I get the absolute value of 0 is less than or equal to 6. Is this a true statement? Yes, it is. And so that means we are going to shade in between those two numbers. If that had been a false statement, we would shade on the outside of those two numbers. So let's take a look at another example. All right, so we have the absolute value of 5p plus 10. And I'm going to go ahead and subtract that 6 over. So is greater than or equal to, and if I subtract the 6 over, I get -45. So again, with absolute value brackets, you just really have to like problem solve and pay attention to what you're doing. Because the absolute value is going to be a positive number. So this statement is always going to be true because anything inside the absolute value is going to be positive. And any positive number is going to be greater than or equal to -45. That's always true. So this answer is going to be all real numbers. And if you wanted to use that symbol, you could. When we go to graph this on a number line, you're just going to shade the whole darn thing in. On the back of your notes, we have a couple more examples. So on C, as I'm rewriting down here just so I have some more space to work, I'm going to go ahead and subtract that 5 over so I get 100 on this side. And then I'm going to divide by 10. So I get the absolute value is greater than 10. Okay, so now I'm going to think of this as an equation. So I'm going to have 5n plus 5 is equal to 10, and 5n plus 5 is equal to -10. So solving both of these, if I subtract 5, I get 5n equals 5, so n equals 1. And over here, if I subtract 5, I get -15 divided by 5, n equals -3. So at 1 and -3, I have to decide what type of point to make. And so again, looking at that inequality symbol from the very beginning, it does not have an equal to. So I'm going to make an open point at 1 and an open point at -3. And then once again, I'm going to test a value outside or in between. I told you guys before, I'm a big fan of testing 0. So I'm going to plug in 0 to the original inequality. It's a little bit more complicated than the one I did before. Okay, so inside the absolute value brackets, I have 5 times 0 plus 5, which is just 5. So this all would be 55. Is 55 greater than 105? No, that's not a true statement. So since 0 is not true and that's in between, I'm going to shade on the outside of those points. You could test values on the outside as well if you wanted to, but just giving you a shortcut there. Okie doke, so let's look at D. First thing I'm going to do is actually add that 1 over. So as I'm rewriting, just know that I am adding the 1 over, so this is now -58. Divide by 2. And I get 1, absolute value 1 minus 3b is less than, and that's -29. Okay, so let's take a look at this. So remember, absolute value brackets are always positive. Is any positive number going to be less than -29? That will never be a true statement. So again, we have a no solution scenario. and we are not going to shade anything on our number line.